Hello friends, in the series of emissions related modeling techniques, today we will discuss about traffic noise emission modeling. So, as you know, like we studied emission modeling in terms of material flow, means something is being emitted in terms of air pollutants, okay, then it disperses and reaches to the receptor. So, we want to know how much concentration of the air pollutant reaches to the receptor. Receptor can be a person or ecosystem or some building or city or whatever, where we want to estimate the concentrations of air pollutants. So, emission modeling we have studied, then dispersion modeling also we have studied. Today we will study noise emission modeling, and the reason behind this is because we want to know how much noise can propagate from the source to the receptor. So, that if the noise levels at the receptor is much higher than the acceptable standards, then we can do something to reduce the noise. Either we have to change something at the source or we have to design noise barriers. You may recall that design parts of the noise barriers, how do we do that? So, that the length of the total distance of the travelling of this noise becomes larger, so that the noise at the end becomes less and less. Okay. Noise is nothing but the energy, you can see, like for example, if you are studying just under the bulb or tube light, the light intensity or illumination is much higher. If you go away from that, the light or illumination decreases. Similarly, noise at the source, it is energy and it is much higher at the source, but as you go away from the source, the noise levels decreases. So, today we will discuss about how to model the noise. Well, so the traffic noise, especially noise can be emitted by many sources, like these diesel generators, okay, DG sets, etc., or maybe some loud music related sources, etc. But our aim is only to traffic noise basically, because we are discussing sustainable transportation system. So, our discussion will revolve around the traffic noise. Okay. So, we will look into different kind of modeling techniques which are available in different techniques, different countries, like in USA you can see this Federal Highway Administration FHWA model. So, that is the model for noise estimating or noise prediction. Calculation of road traffic noise Corton, that is in the UK. Okay. Similarly, in Germany also there is one model RLS 90, and then Acoustical Society of Japan's road traffic noise prediction model. So, that is ASJ RTN model 2008 you can say, in Japan it was developed. There is another model that is known as harmonized accurate and reliable methods for the EU directive on the assessment and management of environmental noise. So, that is in short it is known as harmonize model. This is for European setting. In Switzerland they have their own model which is known as Sonrod model, and then Nord 2000 model is in Scandinavian countries like Norway, etc. And then there is this NMPB roots model for the France, and in Europe another model is common noise assessment methods in Europe, that is CNOSSOS-EU model. So, different techniques are there for traffic noise modeling, as you have also seen, like in air pollution emission inventory related models were several, like IVE, mobile, moves, Copert, etc. Similarly, this noise emission modeling is different in different countries, and they have their different kind of strengths or limitations, and as per the situation we will see in the short after. We will see afterwards implications of these traffic noise model, how do they help us in estimating the noise at the receptor, and how they can be helped by policy decisions related to the noise levels. And then the cause effect analysis of the factors which affect the uncertainty in noise prediction, okay, because even though we have used certain mathematical equations, but there are several input parameters, as you know, in any kind of modeling technique. There are uncertainties because of several reasons, that may be due to input parameters, or that may be due to like calculation related limitations and other factors, which we will discuss, and then at last we will conclude the remarks or the lecture of today. So, when we talk about the introduction of traffic noise models, then basically we want to see that what are the sources of the noise and how noise travels from one place to another, and are there certain mitigation ways or to control the noise. But before controlling or before mitigation, we should know how much noise is there at a particular place. So, these models help us to estimating or predicting the noise because of these vehicular activities. Okay. Then there are like noise maps can be developed, as you might have seen, grid based emission inventory or air quality dispersion, those kind of things. So, here also noise maps are generated by integrating these particular models which are used for traffic noise prediction or estimation with the GIS. So, if we can integrate them with the GIS framework, the noise prediction and control becomes easy to analyze and to do whatever is needed as like interventions, whether it is policy related or technological related, because then you have a map and you know which areas are more affected by noise, which areas are okay. So, those particular areas can be tackled where lot of noise is there. Then these models are nothing but, as I said, these are mathematical equations and they are used through programming. So, some computational environment is needed, plus skilled operators are needed, so that they know how to do programming, how to run the model. So, this is something which is kind of highly skilled kind activity, which only those people who know the programming, who know to convert those principles into certain equations, and then doing input parameters, the reading the file, and then output is taking from this model in certain way which can be understood by policy makers. So, all these things are done by those particular experts who know how to do it. And the examples of different noise models which we have just seen the list, like FHWA for USA, then Corton in UK, and then ASJ RTN in Japan, or RIS 90 of Germany, then Sonrod of Switzerland, then Harmonize of Europe, okay, NOR 2000 for Scandinavian countries, then NMPB routers 2008 which is of France. So, those models we will discuss, what are their parameters, what are their features. Well, when we talk about this FHWA model, the flow diagram, how does it different kind of features, how does it take. So, first of all, the reference energy mean emission level. So, energy is nothing but that noise level. What is the reference level? In comparison to that, we will know that how much noise is increasing or decreasing and how it is traveling. Then the flow adjustment we have to do because of like wind velocity, direction, all those things. Distance related adjustment also we have to do, because as you go away then noise decreases. And then segment adjustment depending upon the topography and other kind of features. And shielding adjustments means if you are using some sort of like noise barrier or some other kind of technique, then those kind of adjustments have to be made, or like earplugs, those kind of thing. Then conversion to equivalent sound pressure level. So, ultimately how much noise is being received by the receptor, and because noise also fluctuates, but we want to estimate as an average value which is like equivalent, okay, we convert it into equivalent value of this noise. So, that predicted sound level is expressed in those terms which we will see, like here this LAAQ. So, this is energy equivalent sound level, okay, LAEQ, that is over a 1 hour time period. So, every parameter has certain definition, and we should follow those definition, those units, otherwise our calculations will be completely erroneous. So, this is the empirical relationship which is used by Federal Highway administration, that is FHWA traffic noise model, okay, in computational those kind of activities. So, the prediction of noise level through the series of adjustments to a reference sound level, that is very important, which we have seen in the flow diagram. So, the reference sound level is nothing but the vehicle noise level referring to the maximum sound emitted by a passing vehicle. So, that we will take as the reference sound level, right. So, maximum possible sound created by a vehicle, and this is for 1 hour reference time and at a reference distance of 15 meter. Okay. That is also like in air quality monitoring, you might have seen that when we talk about ground level measurement, that is like 10 meter above the ground. So, those kind of values have certain sanctity, and we should be quite careful about that. So, this LAQ, energy equivalent sound level over a 1 hour time period, right. Similarly, this one terminology ELI, this is vehicle noise emission level for the ith vehicle type, means different kind of vehicles will emit noise of different levels, like 2-wheeler different, 3-wheeler, 4-wheeler, and within 4-wheeler diesel vehicle have their engines may be working in differently, and they can create lot of noise in comparison to gasoline based noise. So, and then heavy trucks or those heavy commercial vehicles, they will produce different kind of noise, and then tires also play a role, then the surface of the roads, they also play role in creating noise. So, all those things are important. So, here this is basically the type of vehicle related the noise emission. Okay. Then air traffic is adjustment of the traffic flow, because flow also changes from time to time. So, some adjustment we have to do. So, some factors are there basically. Similarly, distance related adjustment factor we have to see, because the distance between roadway and the receiver, and for the length of the roadway, that is reflected in this particular correction factor or adjustment factor. Similarly, AS is adjustment for all ceiling and ground effects between the roadway and the receiver. So, whatever kind of barriers are there in natural way or means man made, whatever, those kind of factors or adjustment related values we have to include. So, that values will give ultimately the 1 hour related equivalent sound level. The basic equations which are used in this particular model are like you can see here. So, this emission of the noise is considered with the help of these constants and vehicle categories, as we have seen different kind of vehicle categories are there. So, these are empirical relationships, you just convert them into programming, and nowadays basically this model has already done this. So, you only to do input values and the model will calculate automatically. We are just giving you idea, understanding of what is happening inside the model. So, that is why we are discussing these empirical relationships which are the part of the model. Okay. So, the noise emission, then logarithmic conversion is there to convert into certain values, that is equivalent related. But there are limitations of this particular model, and those limitations are like vehicles are classified in 3 broad categories. Okay. So, beyond that we are not estimating or predicting any noise. So, that is a coarse categorization you can say. Otherwise, if you go further micro level kind of categorization, then estimated value may be different, but here this is like commercial vehicles, medium trucks and heavy trucks. So, that means small vehicles have not been considered or so. So, adjustments are applied for calculation of hourly equivalent noise level. Okay. So, means different time period is not available. Then the reference distance measurement is taken as 15 meters from the center or the near sight lane you can say, and the actual distance of the measurement is recorded. So, again there are certain limitations in that way also. No separate lane concept for acceleration or deceleration is considered. So, whatever you may recall in Gaussian model, we assumed that the pollutants are inert. Okay. Some very simple assumptions we generally use when we do some modeling, because for every kind of small thing we cannot do these use equations, otherwise that would be very difficult and very resource intensive modeling effort. Then as I discussed, like the mapping with the help of GIS based integration can be done. So, here you can see this GIS based mapping is there for Georgia. They have used this county. Georgia is in the USA. So, as you see the color schemes, so dark this brown or maroon is the maximum value of the noise. Okay. This is the night time, this is the daytime. You can easily see night time noise levels is less than the comparison in the daytime, and the dark brown, that is maroon, is the most noise at the road level. Then as you go away from the road, the noise level decreases. Okay. So, color schemes are given here for knowing about different kind of noise range or level. For UK, this Cortian model is there, and this uses this particular equation. This is developed by Transport and Road Research Laboratory and Department of Transport of the United Kingdom. So, they have developed this model for that particular purpose. In this basic noise level, that is L10 for both 1 hour and 18 hour reference times at a distance of 10 meter from the nearest roadway, that is estimated, and these empirical values are there. Okay, you can see like small q is total hourly flow calculated as a reference distance of 10 meter from roadway at a reference mean traffic speed of 75 kilometer per hour. So, those kind of values are there. Then different parameters are there, you can see these are adjustment related factors, whether traffic flow related or gradient related. So, gradient is something new if you compare the other model, otherwise traffic related adjustment factor was there in that also. Distance adjustment was there in that this model of FHWA, and similarly in this model of Corton also distance related and shielding related are there, but additional adjustments are there like viewing angle, reflection adjustment, those are additional parameters in this particular model. Okay. Then corrections for heavy vehicles and speed. So, delta f is calculated by this particular relationship, right. So, here this V is hourly mean traffic speed in kilometer per hour, P is basically the percentage of heavy vehicles. So, that is to be known for calculation purpose of delta f, and then in percentage heavy vehicles P can be calculated by this particular equation, where Q is total hourly flow and F is flow at particular time period. Well, for Germany they have this another model RLS 90 model, and this is developed in Germany for their own purpose. So, this estimates noise emissions that is at a reference distance of 25 meter, okay, NME, LME, and center line, from the center line 25 meter. So, different distances are there for different models, accordingly assumptions also change, and the noise emission level LME is a function basically of the amount of vehicle per hour flow, amount means Q, and the percentage of heavy truck, as you have seen in the other model also, and the weight is from like more than 2.8 tons under the ideal conditions. So, that kind of truck is known as heavy truck there. Ideal condition is like speed 100 km per hour and road gradient less than 5%, special road surface expressed analytically. So, those kind of factors we have to take into account, and then weighted mean sound level is calculated ultimately LM weighted LME. Then Q is standardized traffic flow, as we have seen as per their norms, and P percentage of heavy vehicles of over 2.8 ton. Well, basic equations in this particular model are again like there is one parameter and then there are some correction factors or adjustment factors. So, basic philosophy is same, you can say in all models, only different kind of range and different kind of parameters or adjustment factors are there, those kind of differences are there. Well, when we apply this noise mapping of Surat city in India using this RLS 90 model. So, in daytime this was kind of scenario was generated for different color scheme, you can see the different noise levels. So, this kind of output can be there. Okay. Then if we talk about Japan, so they have their own model, that is ASJ RTN 2008, and this is the relationship where A and B are basically coefficient values for steady and non-steady flow. Okay. And you can see these are the values like C correction factor, and they have different kind of correction factors related to like pavement material, whether it is asphalt or something else. Okay. And then road gradient is there, and then radiation view angle correction for other factors are there. Well, the key characteristics of this particular model are geometric spreading, and then diffraction effect, and ground absorption, how much energy is absorbed, or the noise energy, sound energy you can say, and atmospheric absorptions also. So, those kind of things are considered this between the receptor and the source. Okay. And then A weighted sound level due to meteorological factors such as wind or reflection and transmission of the sound are considered in this model, and it can be used for various areas like signalized and non signalized road intersections or tunnels or semi underground, okay, depression roads or viaducts, individual building effects, etc. So, versatility is there in this particular model. When we talk about another European model, that is harmonize model, which is means kind of more reliable and accurate. This is in the particular name also. Okay. So, they have different categories. So, its versatility again has good appreciable thing like light vehicles, medium heavy vehicles, other vehicles, motorcycles even, they are also considered in this model. So, quite big range is there for different kind of vehicle category, right. And it also considers the combined effect of air absorption or ground effect or the shielding, which we have seen in other model techniques also. And the basic equations in this particular harmonize model are like rolling noise by this equation and propulsion noise. So, two types of noise we are considering, basically the tire rod related rolling noise emissions, propulsion noise that exhaust emissions and those kind of thing, and because of this movement related way. So, you can see these are the ways to represent, and then the velocity or speed 70 kilometer per hour, and these are the factors which are for different kind of situations. For Switzerland, they have this Sun Road model, and that is basically comprised of two types of vehicle categories only, that is passengers, cars and trucks. So, it is quite coarse if you compare with other models which we just discussed. And then the A weighted sound level for passenger cars is given by this empirical relationship, where again those parameters are similar kind of thing. And for like trucks, this is similar equation, and then speed and then correction factor is there. Those things are to be put for estimating the noise level. NORD 2000 model for Scandinavian countries, that is like 5 main categories of the vehicle they are considering in this. So, again good model in that sense, light vehicles like cars or dual axle heavy vehicles, multi axle heavy vehicles, motorcycles, mopeds also, again very nice in that way. It can go from very small vehicle category, individual vehicle category, to the larger one and medium through medium. So, 8 main categories they are dividing road surface into. So, again versatility is increasing, and the driving conditions are divided into 6 categories. So, they are taking in many situation or many scenarios. So, that is why their estimations may be better in comparison to others. And this considers weather conditions also, like turbulent motions of the atmosphere, meteorological parameters such as wind or temperature related issues, all those things are there because they can affect the energy propagation. Okay. The basic equation is again of course similar kind of thing. Here LR is the sound pressure level at the receiver end, okay, LR, and LW is sound power level within the considered frequency band. And then there are effects, propagation effects for spherical divergence, and then air absorption effect or terrain, ground and barriers related effect. If there are barriers, then noise level will be reduced as you go further. then scattering zones related. So, that way several correction factors are there. And if you consider the France, then they have their own model, which is NMPB routes 2008 model, and this is basically French noise prediction model, as I said, and it categorizes the vehicles into again two broad categories: light vehicles less than 3.5 tons, okay, gross vehicle weight, and the heavy goods vehicle that is more than 3.5 tons kind of weight. So, it is different than the German one, if you remember. Okay. For each vehicle category, they have this sound power level per meter of the line source for unit flow rate, and it is calculated by addition of rolling noise and the engine noise, which is similar to this tire, road and propulsion. So, this is similar, that French model is similar to that particular model. Okay. So, there is another model for Europe, that is CNOSSOS-EU model or CNOSSOS model, that is common noise assessment methods in Europe. That model is also again based on this rolling noise and propulsion noise, same technique you can say. Okay. And the mapping of roads, railways, aircrafts industry. So, this is something extra you can say in comparison to other models. Okay. And the characteristics basically spectral correction factors are needed for rolling noise estimations, okay, for other surfaces with varying kind of acoustic properties, because cement road, asphalt road, those kind of different properties are there, they will produce different kind of noise. And in case of like porous surfaces, the model recommends this application of spectral correction factor on both rolling and propulsion noise sources. So, that situation is to be kept in mind. The model could predict noise in frequency ranges from 125 hertz to 4 kilohertz, you can say 4000 hertz. So, it divides vehicles into 4 categories based on their characteristics, like their weight or their engine kind of technique, or in those categories we can see. Well, when we talk about implications of traffic noise model, so this is the diagram which gives us like what kind of considerations must be there for a good traffic model. So, you can see like accuracy, the precision means as good prediction is there, then this is better. Flexibility means different kind of categories it can be incorporated. Then simple and user friendly, so that if it is very complicated, user will be very less. Then computational speed should be fast and it should be integrated with the GIS. So, similarly like varied meteorological classes must be represented there, road surface, tire corrections or wetness, aging road, impedances, then microscopic traffic simulation for crossings, intersections and roundabouts, that possibility must be there. Okay. And then homogeneous downward refracting propagation conditions or vehicular noise segregation into propulsion and rolling noise, that should be possible. If you want to concentrate only the tire related noise, then you can know. Okay. So, one can switch off other thing you can in the model you can take. So, that way you can categorize the sources and concepts, zone related approaches, harmonized approach in sound propagation, algorithm, strategy for common noise assessment methods. So, all these things must be part of traffic noise model, good traffic noise model you can say. When we talk about cause and effect analysis for noise factors, then basically there may be like source emissions or other factors, sound propagation and road characteristics. So, all these 4 things are there which will influence the noise estimation. So, in source emissions like vehicular speed, that will influence the noise produced. Then vehicular density, if noise is like less vehicles are there and speed is more, then noise from the tires may be different rather than when it is slow traffic. And then steady of intermittent flow, speed distribution, okay, all these things. Similarly, like absorption characteristics of like building facades or minimum measurement time intervals, all these factors, aging effect we have seen, road gradients, then here like meteorological parameters like winds etc., and the ground effect, diffraction effect, all these things are cause and effect related analysis, you can say. All these are in cumulative way, all these factors basically participate in how much noise will be produced, and that way we should take into account in those empirical relationships, so that our model based estimations or predictions are nearer to the real noise level. Otherwise, if the estimated values of the noise levels at the receptor is erroneous, if it is more than, maybe you design barriers much more than the required, so lot of money will be wasted. If it is under predicted, then your noise barrier which you will design based on the basis of that value may be underperforming, and still if we have barrier, we can have more noise at the receptor. So, I mean to say, as much parameters you can use for incorporation in the equations of the models, then it is good, but always there is a trade off, as we have seen earlier also. You can't go beyond complexity of the level of the complexity. So, it should be simple also, and resource related compulsion should not also be there. Well, when we conclude, so we can say that the better models are really difficult to choose, because there are so many things related to gaps or uncertainties which always play their role. And for strategic noise mapping, it is good for, like when we go for consistent mapping, number of people exposed and the noise levels values to them. So, the health effects, other things also can be estimated easily. So, the uncertainties which are in calculation because of different factors, that should be reduced, okay. And this can be used for several kind of things, like in EIE also we use these models to predict the noise level due to certain activity. When some project is coming, some heavy machineries are being used, so how much those stakeholders or workers which are working there in on the site, how much noise will be there, they will be exposed. So, accordingly you have to give some tools, so that they are exposed to less noise level. So, that is why this is very important, and this is all for today. So, thank you for your kind attention, and you can go for additional information through these references. Thanks all, see you again.